Hey Math Plus Squad, welcome to another fun and exciting journey to getting an A in math or maintaining your A in math. If you're not yet a part of the squad, go ahead and subscribe for clear videos and for a chance to win random prizes and giveaways. Now, this is part two of our three-part video series. And so this video will be looking on significant figures. But before we get to that, let's go back to our decimal place question, where we got 34.98265. So first, state how many decimal places the number has. And so you should have realized that it has 5 decimal places, simply because there are 5 digits after the point. You are then to write the number to 4 decimal places, which should be 34.9827. 3 decimal places, it's 34.983, and 2 decimal places, 34.98. Now, when we're writing to 1 decimal place, it's a bit different because you would notice that 9 is in the targeted decimal place. The digit after is 8, which is greater than 5, which means we will need to add 1 to the digits in the targeted place. So 9 plus 1 is 10, which will give us 0. We take 1 over. So the number written to 1 decimal place will be 35.0. The 0.0 is necessary so that it represents the 1 decimal place. In other words, 1 digit behind the point. So I'm sure you got all questions correct. Good job, squad. Good job. Okay, now we're going into significant figures, where we refer to digits used to express the extent of accuracy of a measuring instrument. And so the more significant figures an instrument can measure, the more accurate it will be, the more accurate the measurement that it gives you will be. And so when we are trying to identify the number of significant figures that a number has, we start counting from the first significant figure. And when we go through the rules, you see all of that. Now, let us consider we have this pumpkin. We need to know what the mass of it is. The actual mass is 2.32 kilograms, but we have 3 possible scales that we can use. And so our first scale can only measure 1 significant figure. So the most it will tell us is that it measures, is that the mass is 2 kilograms. We take a second scale, which can measure up to 2 significant figures. And so this scale would tell us that the mass of the pumpkin is 2.3 kilograms. So guess what? We get a third scale, which can measure up to 3 significant figures. And this scale would have been able to give us a more accurate mass for the pumpkin at 2.32 kilograms. So that's the whole idea for significant figures. Now, when we are identifying, as I said, the number of significant figures that a number has, there are some rules that we need to consider. And so the first thing that we need to remember is that all non-zero digits are significant. What are non-zero digits? 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are all non-zero digits and they are significant. So let us take the number 15, for example. 15 has 2 significant figures, 1 and 5. 942 has 3 significant figures. 61,372 has 5 significant figures, 1, 2, 3, 4, 5. Simple. The second thing we need to consider is that zeros between non-zero digits are significant. And again, just reminding you what non-zero digits are, 1 to 9. So if you have a 0 falling between any of those, then the 0 becomes significant. It is counted as a significant figure. So let's say, for example, 702. This number has 3 significant figures. The 7 is the first significant figure, 0 is the second significant figure, 2 is the third significant figure. Or 0 is falling between 2 non-zero digits, so it becomes significant. What about 1042? That has 4 significant figures, 1, 0, 4, and 2. They're all significant. Let's take another example, 5003. These two zeros falling between two non-zero digits, they become significant. So this number also has 4 significant figures. Leading zeros, though, are not significant. And you may be asking what leading zeros are. These are just zeros that appear before or non-zero digits. So if we have, for example, 0.3, this only has one significant figure, which is the 3. The 0 here coming before a non-zero digit, it's not significant. And so this 0 is what we call the leading 0. 0.42, that 2, this 0 here is not significant, and so this number has only 2 significant figures. Although it has 3 digits, it only has 2 significant figures. Another example is looking on 0.02201. Now, these 2 zeros, they are in front of non-zero digits, so they are not significant. However, this 0 here is significant because it falls between 2 non-zero digits. So this number here, it has 4 significant figures. The next point we'll look on is that trailing zeros in whole numbers are not significant. And so our trailing zeros are the zeros that appear after non-zero digits. So 340, this 0 here is a trailing 0. It's not significant, it's just a placeholder. And so this is considered to have only 2 significant figures. 500 has 1 significant figure. 4020 has 3 significant figures. This first 0 here, it is significant because it falls between 2 non-zero digits. However, this trailing 0 here, the one at the back, it is not significant. It's just a placeholder. So we're counting only these 3. Next, we have to establish that trailing zeros to the right or after decimal points are significant. So remember that our trailing zeros are those that come after non-zero digits. Now, these trailing zeros, they become significant if they also come after decimal points. So let's take, for example, 25.0. This 0, it follows non-zero digits, so it is a trailing 0. However, it comes after a decimal point, so it is significant. And so 25.0 has 3 significant figures. Now, let's go back to this example here, where this 0, it is after a point. It's not significant. You may be asking, but yeah, it's after the decimal point. Why is it that it is not significant? It's not significant because it is not following a non-zero digit, right? So remember the rule that we're looking on is that these trailing zeros, for them to be significant, they must come after the decimal point and they must also follow non-zero digits. So 25.0 would have 3 significant figures. If we take 9.00, this also has 3 significant figures. And 4020.0 has 5 significant figures. 1, 2, 3, 4, 5. So this 0 here is significant. Okay. We need to be able to express numbers correct to a specific number of significant figures, and that's what we're going to be looking on now. So if we take, for example, and all of these numbers, we're rounding to 3 significant figures, although the question can ask you to round to any significant figures. It could be 2 significant figures, 5 significant figures, 1 significant figure. It doesn't matter, but for this purpose, we're using 3 significant figures for all our questions. So let's take first 8.7257. We are going to be writing this number to 3 significant figures. Now, unlike decimal places where we start counting behind the decimal point, with significant figures, we start counting from the first significant figure. So in this case, our first significant figure is here at 8. So that's 1, 2, 3. So we're at the third significant figure. Now we need to go back to our rounding off rules. So if the digit after the targeted significant place is equal to or greater than 5, we know the rule. We're going to be adding 1. So 2 is in the third significant position. What comes after is, in this case, equal to 5. So we're adding 1 to the 2. And so this number written to 3 significant figures would be 8.73. Let's look on another example, 1042. Again, we're writing this to 3 significant figures. So we count 1, 2, 3. Notice 4 is in the third significant position. What comes after the 4 is less than 5. So according to the rule, we will do nothing. What we would do, however, instead is to put a 0 there. And this 0 that we're putting instead is very important because with significant figures, we want to make sure that we're maintaining the highest place value. So the highest place value in this number was thousands. Without this 0, the highest place value would have been hundreds. So we need to put it there as a placeholder so that the maximum or the highest place value is maintained at thousands. So unlike with decimal places, we wouldn't have put anything there. For significant figures in a whole number, we would need to put the 0 there as a placeholder. Let's look on a third example, 0.02201, and we're writing this to 3 significant figures. Now let's pay attention to where we would start counting the significant figures from. Unlike the previous, the first 2 examples, we started counting from the first digit because that was the first significant figure. Notice in this example, our first significant figure starts here. So that's the first one, the second, and the third. Writing this to 3 significant figures, 0 is in the third significant position. What comes after is less than 5, so we're removing it, and so we're only left with 0.0220. This 0 is significant. Let's take a final example where we're looking on writing 4020.0 to 3 significant figures. If we're counting 1, 2, 3, we'll realize that 2 is in the third significant place, and paying attention to what comes after is less than 5. So we would think to remove it based on the rules in decimal places. However, we're looking on things happening in front of the decimal point. So again, to maintain highest place value, we would need to keep that 0 as a placeholder. We're referring to this 0 here, right? So only 402 would be significant, and this final 0 here would be a placeholder, not a significant figure. I have some more questions for you. In these questions, you're going to be first stating how many significant figures the number has, and then to write this number to 5, 4, 3, 2, and 1 significant figures. Watch part 3 to see if you got your answers correct, and that's where we're also going to be talking about standard form. So thank you so much, guys, for watching. See you in part 3 as we continue on this journey. We need to get that A in math. We need to maintain that A in math. Math Plus Squad is here to help you guys. Thank you so much. See you in part 3.